Welcome to your Algebra 2 SOL practice video with the items from the 2016 practice set on TestNav 8. Just a moment to talk about some best practices. First of all, think concept, not algorithm. If you're super focused on how to do a problem, but you're not thinking at all about the concept behind it, what it really means, you're probably not doing what you should be doing. When in doubt, write it out. The work written on the paper is going to help you find your answer more consistently than trying to do it in your head. Let the calculator be your helper, not your guide. It's important to remember that the calculator can only do what you tell it to. In the end, just do your best. You'll regret anything less than that. Let's get started with some problems. For each problem, we're going to take a moment to talk about the concept or concepts that are being actually covered by that question. So let's start with this one. Directions. Drag each selected expression to the correct box. Assuming the denominator does not equal 0, completely simplify the following expression. And then we have a rational expression. Rational because it includes fractions. That's our first concept here. We're dealing with fractions. Second of all, we're dealing with division of fractions. That means that I want to be thinking about how I keep the first fraction, switch it to multiplication, and then flip the second fraction over, because that's how we do division with fractions. We multiply by the reciprocal. Next, I want to be thinking about the fact that I can factor each of these expressions at least a little. Well, almost all of them. And then finally, I'm going to think about canceling out. Canceling or crossing out common factors. So let's go ahead and actually do the math for this. So I'm going to look at each of the four parts of this expression and see how I can factor it. I also want to look for patterns at the top and the bottom, and diagonally they'll be able to use to cancel things out. So looking at this first expression right here, well, I don't normally have a negative on my squared or quadratic term. I don't normally have that. So I want to get rid of that. So I think I'm going to factor out a -1 from all of this. Look down here. Well, this kind of looks like a difference of squares. Now, a difference of squares is where you have a square, a perfect square here, and a perfect square here, and subtraction in between. But it's kind of backwards from what we're used to, so let's take a -1 out of that one also. So that's the first thing I should recognize here, is that I can take a -1 out of the numerator and make it 2d squared minus d minus 15. And out of the denominator, making it d squared minus 9. Now I want to stop and think about what we talked about a minute ago. We're dealing with fractions, and we're dealing with multiplying fractions. So I'm going to go ahead in this step, and I'm going to switch this to multiplication, and I'm going to flip this baby over. So I'm going to put the 2d squared plus 11d plus 15 on the top, and I'm going to put 4d plus 1 on the bottom. So I've already dealt with the fact that it's dividing fractions, which is going to become multiplying here. Now I want to deal with some factoring. So I'm already noticing here that my -1s are going to cancel out. So I'm going to cross those out. I can also see that the denominator here is a difference of squares. So that is going to be the square root of the first thing, the square root of the second thing, 1 plus, and 1 minus. And that's the pattern there. Now I'm going to factor this numerator. Well, there's a lot of different ways to factor. Hopefully at this point, you've gotten to the point where you can factor comfortably. So I don't want to spend a whole lot of time going over that in this video. If you need help with factoring, talk to the teacher that's running your remediation group and get in there and get some help with the actual mechanics of factoring. But what I'm going to go ahead and tell you now is that this is going to end up being 2d and d, and this one over here is going to be a -3, and this one's going to be a +5. Okay, so right here we have 2d plus 5 and d minus 3. Over here for this one, with the 2d plus 11d plus 15, it's going to be similar, but it's going to be 2d and d, and that's going to be +3 and +5 here. Okay, so again, I'm not going to spend the time reteaching factoring. We can find another way to help you review that. But what I am going to do now is I'm going to notice what I now have. I now have 2d, let's switch colors again, 2d plus 5 times d minus 3 on the top, d plus 3 times d minus 3 on the bottom, and now I'm multiplying that by 2d plus 5 and d plus 3, and then finally on the bottom the 4d plus 1 that I never touched. And I'm going to go through and cancel out what's common. Well, the d minus 3's cancel out because top to bottom they have the same value. That means they cancel out and they give you a value of 1. It's like dividing something by itself. That's why it, quote, cancels out. The d plus 3 and d plus 3, they also cancel out because, again, top and bottom. Even though it's diagonal, it still acts the same way as the d minus 3's did. Which means I now have my answer. I have 2d plus 5, another 2d plus 5, and a 4d plus 1. So 4d plus 1 would have to go in the denominator. Right here would go here into the denominator. And then 2d plus 5, the quantity squared, that would go into our numerator. Okay, so yet another question with fractions. So again, let's talk concepts here. Fractions, first of all. We also know that just because there's a big fraction bar in the middle, that shouldn't stop me from writing it as if it's division of two fractions. So again, we've got fractions, and again, we've got division of fractions. And one more time, we want to be thinking about how when we divide two fractions, we actually multiply by the reciprocal. So let's try it. So in this problem, I'm going to rewrite it. And I'm going to rewrite it in a way that makes it a little bit clearer in my head what I'm doing. I have negative 13 plus d over 42d cubed divided by 13 minus d over 6d to the 9th. Much better. That's a lot easier to see what I'm actually doing here. I'm dividing, which means I'm going to go ahead and do that math where we already talked about this. I'm going to keep the first fraction, switch it to multiplication, and flip the second fraction over. And now I can start canceling things out. Well, first of all, let's notice that negative 13 plus d right here, negative 13 plus d, and 13 minus d, those are close, but they're not identical. I could rewrite this right here as d minus 13. And in order to get this into a d minus 13, I'm going to have to divide out a negative 1. But now that I've done that, the d minus 13 here and the one over here, they get to cancel out. I still have that negative 1, notice that. And now I'm going to look at the other two parts of the fraction, the numerator on the right and the denominator on the left. Well, 6 goes into 42 7 times, so I'm dividing them both by 6. D cubed would go into d to the 9th, leaving me 6 of those. So canceling out, 3 of them cancel out with 3 of the ones up top. So what does that leave me in the end? Well, up here in this part of the fraction, I have nothing, so I have a 1, essentially. Remember, it's not a 0, because you can't multiply by 0, it's a 1. Over here, I have d to the 6th, and then over here, I have a 7, and then over here, I have a negative 1. So what do I have? I have d to the 6th on the top, and I have 7 times negative 1, or negative 7 on the bottom. But I'm going to put my negative out front instead of up top. And really, I could put it either way. I could put it up top, or I could put it out front. We don't normally put negative signs in the denominator. So that means the correct answer to this problem has to be negative d to the 6th over 7, which is right here. Whoop, wrong pen tool. There we go. Okay, so let's take a look at this next one. Okay, it says which expression is equivalent, and it gives us a cube root. So we're dealing with a radical, in this case, a cube root. A cube root is one where you're finding what to the 3rd power equals the insides of that radical. So I know I'm going to have to deal with perfect cubes. I'm probably going to have to find the factors of the expression inside, and I'm going to have to figure out how to simplify when I have a monomial. That means a multiplied term that's got numbers and variables and exponents in it. So I'm simplifying this radical. And I have a couple of different options on how to do this, but I'm going to do this one from scratch and not use the calculator to help me through it. I'm going to start by looking at how I find the cube root of 576. We'll deal with the variables in a minute. Let's just deal with the number for now. Well, for me, I'm going to use an old skill from back in middle school. I'm going to make a factor tree. So 576 divided by 2, that's 288. Divide that by 2, that's 144. Divide that by 2, that's 72. Divide that by 2, that's 36. Divide that by 2, it's 18. One more time, you get 9. And finally, 3 times 3. So 576 is made up of 1, 2, 3, 4, 5, 6 factors of 2, or 2 to the 6th, and then 2 factors at the bottom of 3, which is 3 to the 2nd. All right, so remember a minute ago I said we'd come back to the variables. Now we're going to come back to the variables. It's n to the 8th power. I'll put my dot in between for just to make it easier to read. And then p to the 27th. Ooh, don't get confused by my factor tree here. That's just off to the side. Now I'm going to look at what I'm finding. I'm finding the cube root. A great shortcut for these problems is to divide the exponent on each factor by the index. That's this number out here. Cube root means that I'm finding the number that when you put it to the 3rd power, you get this value. So when we use cube roots, one shortcut, one way to do it, is to divide the exponent divided by the index. If it comes out evenly, which this one does, that's going to come out front in our answer. So that part's gone. But for this next one, 3 to the 2/3, well, that doesn't go out evenly. So that means that our answer is going to still have the 3 to the 2nd power, or 3 squared, or 9 in it. The next one would be n to the 8/3. Well, that almost divides. That goes in 2 times with 2 left over. So we put 2 out here, and then the 2 that's left over goes in there. And then we have p to the 27th, 27/3, that's 9, that comes out evenly, so p to the 9th. So the correct answer here is 4n squared, p to the 9th, times the cube root of 3 squared. Oop, we don't want to put 3 squared there, we want to go ahead and put what? 9, and then n squared. So our correct answer here must be A. Okay, another radical question. So this is a 6th root. So the concept we're dealing with here is, first of all, the 6th root. So we're finding what to the 6th power equals all of this. And we've just gone over the other concept, which is rational expressions, that you take and you divide the exponent divided by the index, and that simplifies that expression. Let's give it a try. We'll start with the 6th root of 729. And I'm going to let my calculator help me for this one. I believe if you go to your math button, you'll be able to find the X root button. And you can put the 6 out front and find that the 6th root of 729 happens to be 3. From there, now we want to think about how we would express each part of this. We talked about exponent over index. So Q would be to the 17/6. And then same thing, R, exponent over index, 11/6. So there's one of the correct answers already. 3Q to the 17/6, R to the 11/6, so that's this one. But we're going to assume that there's another correct answer somewhere here. And I'm thinking that maybe it's one of the ones that's expressed as a radical. Now, why are these questions, or why are these answer choices, I should say, here? 729/6 is not how you solve this. We're finding the 6th root of that number, not dividing it by 6. So I automatically know that none of these can be correct. I also know that this is upside down, and so that can't be correct either. I also know that 17/6 does not equal 11, so that can't be right. But let's look at this last one. Could that possibly be correct? Well, let's do what we did on the previous question. We have our 3. Let's simplify these expressions here, these fractions that we have as exponents, these rational exponents, because that means fraction. When they say rational, they really mean fraction. So 17/6, let's get the right tool. 17/6 is equal to 2 5/6. 11/6 is equal to 1 5/6. So for the Q portion of our expression, That means that outside the radical sign, we're going to have q to the second power. But inside the radical sign, we're going to have q to the fifth power. Same idea over here. Inside the radical sign, we're going to have r to the first power. And then inside the radical sign, we'll have r to the fifth power. So outside first power, inside fifth power. And then we still have our 3 sitting out front, which means this is our correct answer. Our second correct answer. This next one involves factoring, everyone's favorite concept in Algebra 2. This is involving factoring with a difference of cubes. So the concepts we're looking at here are factoring. We're looking at the answer to be equal to the original expression. So that's something you can use your calculator possibly for if you know a trick for that. And we're looking for patterns. The pattern of how the perfect cubes, or the difference of cubes, sorry, the pattern of how that's going to be laid out. So whenever you're factoring a difference of cubes or a sum of cubes, there's a pattern here. And if you know the pattern, you can factor the expression. Let's use the expression a cubed minus b cubed. When you factor that, you're going to get a binomial, that means 2 terms, and then a trinomial, that means 3 terms. And the pattern will always be the same kind of binomial, the same kind of trinomial. In the binomial, you're going to have the cube root of that first term minus the cube root of that second term. And then in the trinomial, it's going to be that cube root squared plus the product of those 2 cube roots plus that second cube root squared. So in this problem, when we're factoring this, we have the expression 125m cubed minus 343. So the first thing you do with this problem is you figure out what's cubed in the expression. Well, in this one it's 5m, and in this one it's 7. And that means that your a, the value that goes into this and this and this spot, that's 5m. And your b, the value that goes into this and this and this spot, that's 7. So now we just plug it in. So the binomial is 5m minus 7. Well, that doesn't help answer our question. They all have 5m minus 7. But we'll notice a definitely is wrong because that's not how you would multiply this out. It's got to be binomial, trinomial. Next, we're going to have 5m, but we're squaring that. That means we're squaring the 5 and the m. And you can see that, even if you didn't remember that, you can see that in your answers. Look, they all have 25, not 5. Then it's going to be plus, and it's going to be the product of the 2. 5m times 7, then it's going to be plus 7 squared. So that means I have 25m squared plus 35m plus 49. That means B is my correct answer with that trinomial and the 5m minus 7 sitting out front. Okay, on this next one, we're looking at a polynomial function, or at least we're looking at the zeros of a polynomial function. It says select all the correct answers. The zeros of a cubic function, f of x, are -1, -2/3, and 5. Select all the factors of f of x. So quickly, what are we talking about here in terms of concept? If I'm looking at a polynomial, and just in the interest of drawing a picture, this is not the polynomial that we're talking about in this problem. But if I'm looking at this polynomial right here, this is a function, and I know the zeros of the function. I know that's this, this, and this are zeros of the function. If I know those are zeros, I can also find out what the factors are. Because if I work backwards, I can take the 0 and put it into a factor like the ones you see up here. It involves switching the sign, working backwards. So those are the concepts we're looking at for this problem. Let's try it. Okay, so first of all, if -1 is a 0, then x minus -1 is a factor. That means that x plus 1 is one of the factors we're looking for, and that's this one right here. If -2/3 is an answer, we write x minus -2/3. Now this is a little different because our factors are never going to have fractions in them. We rewrite that as x plus 2/3, and then we're going to multiply both terms by 3 to get rid of that fraction. 3x plus 2, Let's try that again. 3x plus 2 is our second factor. And then the last one, x minus 5, and that's our third factor. So the zeros, reverse the sign, put them in that binomial, that's your factor. Okay, this next question involves sequences. It involves something called a recursive sequence. It says type your answer in the box. The following sequence is given in recursive form. Well, what does that mean? Well, it means that they tell you the first term, and then they tell you how to find every term as long as you know the one that came before it. So any term is the one that came before it times 2 plus 5. So the concept we're dealing with here is using a formula. Using a formula and understanding what it means. Let's go ahead and do the question. So if the first term is A1 is 8, in order to find A2, you would have to multiply 2 times A1. You see this here? AN minus 1, meaning the one that came before it. And then once we do that multiplication, we'll add 5. So to find A2, it's 2 times 8 plus 5, or 16 plus 5, which is 21. So that's A2, but that's not what they asked us to find. They asked us to find A3. So that means we multiply 2 times the one that came before it, plus 5, which is 42, plus 5, 47. And that's our answer for that question. Okay, so this next one says select all the correct answers, and it has an absolute value equation. And this question involves us clicking on a number line. It doesn't tell us how many correct answers there are. It doesn't give us any indication how to find them. It just tells us click them on the number line. So an absolute value equation is the first concept we're looking at here. Graphing on the number line is the second. Now we want to think about how we solve an absolute value equation. And what I want you to remember is absolute value always solve 2. Value 2. They rhyme. Absolute value solve 2. What does it mean to solve 2? Let's take a look and actually do the problem. When I say solve 2, I mean that you're going to solve the equation once, taking off those absolute value bars. Because if I take off the absolute value bars, that's true for this equation. You're also going to solve it a second time. I'll put a little dividing line here, where you have, forgot the x, you have the same thing from the left, but you reverse the sign on the other side. Because the deal here is that the insides of this absolute value could be positive 1/2, or it could be negative 1/2 for the actual absolute value to come out to a positive 1/2. And now these are the two equations I'm going to solve. So to solve these, I'm going to switch colors so we can see the work. We start by getting rid of the fraction. So I'm going to multiply this entire equation by 8. 8 times an eighth is 1, so 1x. 8 times a fourth, that's 2. And 8 times a half, that's 4. Add 2 to solve. X equals 6. Over here, same thing, going to multiply by 8. 8 times an eighth, that's 1. Minus 8 times a fourth, that's 2. Equals negative 1/2 times 8, that's negative 4. Same thing, add 2 to each side. And we get x equals negative 2. At this point, you can go back, you can plug those answers in and make sure that they work. Remember to use your calculator to help you. And remember that it's okay to get a negative 1/2 on the insides of this expression as long as those absolute value bars are there to get you to a positive 1/2. So in the end, when I solve this problem, and once I've checked it, I would go ahead and plot those 2 points right on the number line. This question says that the solution to a quadratic equation is given, and it's an expression with an imaginary number. So the first concept here is imaginary numbers. The next concept here is that it's asking us to find another solution. Well, this is all about knowing that the solutions that are imaginary to some polynomial always come in what's called conjugate pairs. Conjugate pairs are found by changing the sign in the center of the solution that's in the form a plus bi to a minus bi. What's the correct answer here then? Well, if the first solution is negative 16 minus 8I root 35, we switch that sign in the middle, and it's negative 16 plus 8I root 35. The reason they come in conjugates, that means it's this one, the reason they come in conjugates is because that way you can cancel out the imaginary numbers when you multiply it out. All right, this is a radical equation, a square root equation. So what concept am I looking at here? I'm looking at a square root equation. I want to isolate the square root, I want to get rid of the square root, and then it's really important that I check my solution. So let's write out the solution for this. Okay, the first thing we have to do with this is isolate the square root. So I'm going to subtract 6 from each side. That gives me 3 times the square root of 2x minus 4 is equal to negative 3. Well, at this point, hopefully, I notice something. I have a problem. This says that 3 times the square root is equal to a negative number, and that is impossible. So at this point, I know there's something wrong with this problem. But I recognize that really quickly. What would happen if I had kept going? So pretend I didn't recognize that. Let's keep going. After this step of 3 times the square root of 2x minus 4 equals negative 3, I would divide by 3. The 3's here would cancel, and I'd have the square root of 2x minus 4 is equal to negative 1. Now, to get rid of the radical sign, I would square both sides. That gives me 2x minus 4 on the left and positive 1 on the right. Continuing with the process of solving an equation, I'm going to add 4, meaning 2x is equal to 5, and x would have to equal 2½ or 5 halves, and that answer is most definitely there. However, if I go back to the beginning and I plug that answer in, let's try it. 2 times 5 halves inside the radical minus 4, and then a plus 6. Well, what do I get? 3 times the square root of 5 minus 4, that's 1. So square root of 1 plus 6. So 3 times the square root of 1 is 3 plus 6, that's 9, but the equation says it equals 4 or 3. Well, that's not true at all. That means this equation has no solution. And the part that messed us up from the very beginning was right here when we tried to say that this radical would be equal to a negative number. Either way, as long as you follow the process, you'll find the correct answer. It's D. This problem gives you a system of equations. That's 2 functions or 2 graphs of something on the same coordinate plane at the same time. Most of the time, they cross. And so you end up with ordered pairs where the 2 graphs would intersect with each other. And this question is asking us to find the y coordinates for those intersection points. So we can solve this algebraically. That means written out on paper. We can solve it graphically. That means with your graphing calculator. And if you have the Conics app, you can definitely use your calculator to do this. But let's do this on paper because that's what we're here for. So I'm going to take this problem and I'm going to do something called elimination. The first equation has in it an x squared, an x, and a y. Well, I want to get rid of that y. So what I'm going to do is I'm going to take this second equation, x plus y plus 20 equals 0. And I'm going to multiply the whole thing by a negative 3. That's going to give me negative 3x minus 3y minus 60 equals 0. I also have x squared plus 6x plus 3y plus 6 equals 0. That was my other equation. But if you look now, if I try to add straight down my 2 equations, which is something you're allowed to do, you're taking 2 equal things and adding together with that 2 more equal things. You'll still get 2 equal things. So if the left side is added to the left side and the right side is added to the right side, we still get something that's equal. All right, so if we go straight down, I have x squared, I have plus 3x. The 3y and the minus 3y cancel out, and then I have minus 54. Well, that's a quadratic equation, and I'm supposed to solve that. So however you solve that, I'm going to do it by factoring. You're going to find that the correct answer for the x values here is going to be positive 6 and negative 9. If I then go back and I plug in each of those numbers into, let's pick the second equation because it's easier, and I solve for y, I can find my y coordinates. So, negative 9 plus y plus 20 is equal to 0. That means y plus 11 equals 0 and y equals negative 11. So that's one of my answers, which means actually I'm kind of done. Let's just check the other one just in case. So we plug in the 6 for x, plus y plus 20 equals 0. So y plus 26 equals 0 and y equals negative 26. Yep, there's the other one. All right, you've made it through the first set. Up next, part 2. Thanks for watching.